Hi, this is the project phase 1 presentation by AlphaDB group. Our group members are Lei Guo, Zhenchao Cai, and Ruopeng Liu. We use 3 Amazon EC2 computers to create the cluster. Here, server 1 is the master, server 2 is the worker 2, and server 3 is the worker 3. I have studied the Hadoop and the Spark on all of the computers. Here we can see the overview of the Hadoop. We have 3 live nodes. Here is the UI of the Spark master. And here we can see we have 2 workers. Next, I wanted to show we have created a bidirectional passwordless SSH access between the worker and the master. Firstly, let's show the IP address of all the computers. Here we can see the master, worker 2, and worker 3. And we can see we are at the master. Let's show that we can connect to worker 2 without a password. See, we are at worker 2 now. Now let's connect to master from worker 2. Okay, we are at master now. This shows that we have created a bidirectional passwordless SSH access between the master and the worker 2. Next, let's show that we have created the same thing between master and worker 3. Let's go back to the master. Next, let's connect to worker 3. Okay, we are at worker 3 now. Let's connect to master. Okay, we are at master now. Let's go back to master. Next, let's load the data into a Hadoop file system. Before load the data, we want to create a directory first. The name of the directory is the test data. Next, let's load the data into the directory we just created. Let's show that the data is on the following directory. This is the point data and the query window data. Now, let's put them into the Hadoop file system. Okay. Next, let's show that they are at the correct position. Okay, here we can see the URIs to both the query window data and the point data. And we will use them later in the Spark shell. Next, let's open the Spark shell. We also want to load the GeoSpark library when opening the shell. Okay, we opened the Spark shell. Now we can play with it. First, let's create a GeoSpark spatial RDD. Of course, we use the data we loaded to the Hadoop file system before, which is the point data. Done. Now we have the point RDD object. Next, let's do the range query without index. We create the query window with the data from the project requirement. You can see it here. And finally, let's do the range query. Okay, we have the result now. The result size is 445. Next, let's do the range query again, but we do it with the arbitrary index. Okay, we also have the result. The result size is the same. It's 445. We created the arbitrary index like this. Next, let's do the spatial KNN query without index. Okay, we find the 5 nearest neighbor. Next, let's do the same KN query again with the arbitrary index. Everything is the same except that we build the arbitrary index on the point RDD. Okay, we have the same result. The result size is also 5. Next, let's do the spatial join query using equal grid without arbitrary index. Here we create the point RDD with the point data from a Hadoop file system, and we created the rectangle RDD from the query window data, also from a Hadoop file system. We used equal grid spatial partitioning. Let's do the query. Okay, now we have the result size. It's 25,743. Next, we will do the same join query with the equal grid and arbitrary index. Everything is the same as the previous task, except that we build arbitrary index on the point RDD. We are done, and the result size is the same as the previous task. Finally, let's do the spatial join query using arbitrary grid without arbitrary index. Here we can see we are using the arbitrary as a spatial partitioning. We are done. The result size is the same. That's the presentation for our project phase 1. Thanks for your watching.